And within biology, my experience within biology is that the biggest problem of biology is that you can't see what's going on. You have very little ability to see what's going on and even less ability to change it, right? What you have is this, like from this, you have to infer that there's a bunch of cells that within each cell is, 3 billion base pairs of DNA built according to a genetic code. And there are all these processes that are just going on without any ability of us as, unaugmented humans to affect it. These cells are dividing. Most of the time that's healthy, but sometimes that process goes wrong and that's cancer. The cells are aging. Your skin may change color, develops wrinkles as you age. And all of this is determined by these processes, all these proteins being produced, transported to various parts of the cells, binding to each other. And in our initial state about biology, we didn't even know that these cells existed. We had to invent microscopes to observe the cells. We had to invent more powerful microscopes to see, below the level of the cell to the level of molecules. We had to invent X-ray crystallography to see the DNA. We had to invent gene sequencing to read the DNA. Now, we had to invent protein folding technology to predict how it would fold and how they bind and how these things bind to each other. We had to invent various techniques for now we can edit the DNA as of, with CRISPR as of the last 12 years. So the whole history of biology, a whole big part of the history is basically our ability to read and understand what's going on and our ability to reach in and selectively change things. And my view is that there's so much more we can still do there, right? You can do CRISPR, but you can do it for your whole body. Let's say I want to do it for one particular type of cell and I want the rate of targeting the wrong cell to be very low. That's still a challenge. That's still things people are working on. That's what we might need for gene therapy for certain diseases. And so the reason I'm saying all of this, and it goes beyond this to gene sequencing, to new types of nanomaterials for observing what's going on inside cells, for, antibody drug conjugates. The reason I'm saying all this is that this could be a leverage point for the AI systems, right? That the number of such inventions, it's in the mid double digits or something, mid double digits, maybe low triple digits over the history of biology. Let's say I have 1 million of these AIs, can they discover 1,000, working together